Hello and welcome again as we look at yet another multiple choice question for IB Chemistry. This one dealing with topic 1 stoichiometry, and it bears close resemblance to a previous question that I shared. To access that question, you can click on the card above here, or you can click on the link in the caption below this video. But let's take a look at the question now, and it says, which expression, and these four expressions here, gives the sum of all of the coefficients, which are these numbers missing here, for the general equation for the complete combustion of hydrocarbons? Well, when this question appeared in the exam, some teachers felt it dealt more with mathematics and less with chemistry. But there is a way to go about solving it. And this, of course, provides more evidence as to why students in preparing for examination day in IB Chemistry, why you need to practice with the past exam questions like this one, because it could be a little bit off-putting for you in the exam to see something like this that looks quite unfamiliar. But even though it is unfamiliar, there is a way to solve it, and that way is to go back to what you are familiar with. And you are not expected to memorize this formula, this general expression, to balance these equations. But the question itself provides you with some useful information that you could apply to other questions. But let's look at how to arrive at the answer out of these four here. And the simplest way to do that is to substitute x and y with the simplest whole numbers that you can think of, the simplest hydrocarbon that you can think of. And that would be where you make x into a 1 and H into a 4. So in other words, you are getting the familiar CH4, methane gas, and then you go about balancing this equation using the method that I shared previously on that last video, which you can click up here or down below. You look at the carbons first. There's one carbon here, so let's imagine we only need one here. There's 4 hydrogens here, so we need to put a 2 in front of here. Let's see if that balances the oxygens. 2 multiplied by 1 is 2. 1 multiplied by 2 is another 2. So that's 4, so we'll need to put a 2 in front of here. And then 1 here, 2 here. A 1 is understood there as the coefficient that goes with each formula. Then plugging x and y into one of these. If you plug x and y, which is x, we said equal to 1, and y equals 4. If you plug that into answer C, you'll get 4 multiplied by 3, 12, divided by 4, plus 2 multiplied by 1, 2, plus 1. That's 3 plus 2 plus 1 equals 6. And 1 plus 2 is 3, plus 1 is 4, plus 2 is 6. So the answer to this question is C. You can apply this formula here, noting that x equals 1 and y equals 4. And using this formula, you would get the sum of all of these coefficients. Now that does not necessarily mean integer coefficients. In cases where you do have something like C3H6, when you do balance the equation, for this to be satisfied, you need to work with halves. And that is why it's not always the best thing to apply this formula, but simply to balance the equation like we have it. Let's take another example from another question now. And here we have another more familiar type of question. What is the sum of all coefficients for the combustion of propane? Now, they didn't mention here that these coefficients need to be whole numbers or integers, but let's balance this equation following the method that we've been using previously. C3, so let's put a 3 here. H8, so let's imagine that we need to put a 4 in front of this H. 4 multiplied by 1 oxygen, 3 multiplied by 2 oxygen, so it's a 6 plus 4, that's 10. It means we need to go with a 5 in front of here. We need to leave this as a 1, leave this as a 3, and leave this at 4. 4 multiplied by 2, that's 8. 4 multiplied by 1, that's 4. 3 multiplied by 2, that's 6. 6 plus 4, 10. 5 times 2, 10. 3 carbons, 3 carbons. So this equation's all balanced. The sum of the coefficients, 1 plus 5 is 6, plus 3 is 9, plus 4, 13. And you arrive at the answer for this question C. But what about that formula that we just saw? Is that formula going to be satisfied in this case? This formula here, where 3 refers to x and 8 plugs in for y. So 3 multiplied by 8, that's 24. Divided by 4, that's 6. 2 multiplied by 3, that's 6. Plus 1. A total of 13. So here again we have integer coefficients, and again the formula is satisfied. But you must realize that in plugging in this formula, sometimes your answers will be fractions. An example of where you will get fractions is if you tried to use this formula for C3H6. You would get fractions. When you get fractions, of course, if you're using this formula, you simply need to multiply by the appropriate number to remove those fractions. Like if you get 4.5 for oxygen, you multiply everything across by 2. And 11.5 would become 23, which is what you would get with C3H6. You could try C3H6 now. Go back, write the balanced equation for it using whole numbers, using integers, and then take C3H6 and plug it in to this formula, and you realize that you'll get 11.5, because this formula deals with coefficients, not necessarily integers. Coefficients are numbers which can be fractions that come in front of each formula, but whole numbers or integers are what is required in standard chemical equations.